Okay, hello and assalamualaikum to Dr. Rail. So today we are from group 6 and we'll present our progress as of for now for the mid-semester evaluation.
So hi, hello, assalamualaikum, and a very good day. My name is Siti Nur Syaza and I'll be presenting about the general overview of the alternative one. So basically, in this alternative, we do have 3 reactor and also 1 distillation column. The first reactor will be the hydrocracking, where it will crack the aromatics to saturates, which will increase the viscosity index. Next, it will proceed to the hydrodewaxing reactor, where it will change the N-paraffin to I-paraffin and it also will reduce the melting points. Next reactor will be the hydrofinishing reactor, where it will increase the oxidation stability and also it will improve the color of our desired product. And we will end our process with the fractionator, where it will separate our main product and also our side product. So we will end it with the group 3 and group 3 plus base oil. So for the justification of this design is that there is no hydrating reactor because of the small amounts of nitrogen and hydrogen sulfides in the feed stream. We also do need mixer before entering the hydrocracking reactor because we do have 3 feed streams from the vacuum distillation unit, and we also need a high discharge pressure pump or intermediate tank as our feed is in a vacuum state. And why we do choose this alternative is because we will surely will get the end products of group 3 and group 3 and above of the base oil.
Assalamualaikum and good day to Dr. Raid. I'm Qamarina. I will be explaining the advantages and drawbacks of alternative wine, which is the integration of hydrocracking, hydrodewaxing, and hydrofinishing. The first advantage is it can produce high yield of base oil compared to alternative 2 because in alternative 2, we are completely removing the aromatic. In alternative 1, we are converting the aromatic into a useful compound. Secondly, it can produce high quality end product. The quality can be measured with the aromatic content. As we can see from the slide, the product from the hydroprocessing is white in color. If the product contains high amount of aromatic, it will be bright yellow in color. The third advantage is it can produce group 3 and group 3 plus base oil. Group 3 plus base oil has viscosity index more than 120, which is the one that is desired for this PDP project. Lastly, the catalyst used for this project can last up to 6 regeneration cycle, which is quite long. So we can save our operating costs. For the drawback of alternative wine, first it requires purification of hydrogen. Because for this alternative wine, we need to recycle back our hydrogen as the makeup hydrogen. In order to recycle the hydrogen must be purified first. Due to that reason, some hydrogen is purged along with the contaminant. So some hydrogen must be top up using the makeup hydrogen stream. Secondly, it requires temperature control at the reactor because this reaction is exothermic. Exothermic means the reaction release some heat. So hydrogen is recycled. Some of the hydrogen recycled is used to quench the back inside the reactor to lower the temperature as heat is being released during the reaction.
Hi, my name is Muhammad Danish bin Rozidan. For Alternative 2, Alternative 2 is a series of solvent extraction, solvent dewaxing, hydrofinishing, and fractionator process unit. The first process unit is solvent extraction. Solvent extraction use liquid-liquid separation to remove the aromatics content in vacuum gas oil. The most common solvent used is furfural. By removing the aromatics, the raffinate will have higher fraction of saturates compared to aromatics, subsequently increase the viscosity index. Next, solvent dewaxing. Solvent dewaxing is used to remove the long hydrocarbon chain to reduce the pour point. Raffinate from previous solvent extraction process is then mixed with solvent such as methyl ethyl ketone and toluene to dilute the raffinate in solvent dewaxing process. Next is hydrofinishing. The purpose of hydrofinishing is to increase the oxidation, stability, and improve color, as mentioned in alternative 1. Oxidation stability is the resistance of oil to form deposit, sludge, and corrosive byproduct in engine and industrial oil application when under extreme heat and pressure. A better oxidation stability consequently will make the color of the base oil become clear. Lastly, a fractionator will use to separate main product and the side product. The justification of the design, as in alternative 1, there will be no hydrotreating reactor because the feed can be considered as sweet crude as it contains small amount of nitrogen and sulfur. Next, a mixer needed before hydrocracker to mix the feed homogeneously, and a high discharge pump also needed as the feed pressure is in vacuum. This alternative can only produce one Group 1 and Group 2 base oil.
Hi and a very good day to Dr. Roel. I am Luqman Hakim and I will be explaining on the advantage and drawbacks for alternative 2. For alternative 2, it only has one advantage where it requires less amount of hydrogen gas because for this alternative, it is integrations of solvent extraction, solvent dewaxing and hydrofinishing. Hence, it's only use hydrogen at hydrofinishing part. Next is the drawbacks for alternative 2, where the first one is produce lower yield of base oil compared to alternative 1, because in alternative 1, we are converting the aromatics into useful compound, while for this alternative, we are completely removing the aromatic. Secondly, this alternative also requires solvent purification, and thirdly, low selectivity of solvent use. The last drawback that we find in this alternative is low quality end product. The quality can be measured by the aromatics content. As you can see, this alternative seems to have more drawbacks compared to advantage, and that is why we choose alternative 1 compared to alternative 2.
Okay, hi, I am Nur Hidayah and today I will be explaining about process flow diagram. So from here, as it's stated in problem statement, our feed will come from a vacuum distillation unit. So and then the first unit that we'll be going through is a hydrocracker. So however, before that we will be using a heater to heat up the feed until it reach the temperature, inlet temperature of hydrocracker. And okay, so first let me recap. Hydrocracker will be used to crack the aromatics to saturate, which will also increase the viscosity index. So to simplify, hydrocracker will crack the long chain carbon into shorter chain. So the operating temperature of hydrocracker is around 260 to 480 degrees Celsius with a pressure of 800 to 3000 psig. And we propose to use a catalyst of nickel molybdenum as a catalyst for the hydrocracker. So after it goes to hydrocracker, it will go to a hydro-dewaxing. So hydro-dewaxing is actually to change the N-paraffin to isoparaffin. In the other words, will be isomerize the feed. So this is why, this is because we want to decrease the pour point, and for hydro-dewaxing, the operating temperature is 275 to 425 degrees Celsius. But and the pressure is around 300 to 3000 psig, and we propose to use one zeolite for the catalyst, which is ZSM11, as it consists of medium pore size. Okay, so after we go through hydro-dewaxing, we will go to hydrofinishing. So the purpose of hydrofinishing is to improve the product quality, as it will improve our oxidation stability and also color. So the operating temperature for hydrofinishing is 200 to 350 degrees Celsius with pressure of 200 to 3000 psig. And the catalyst that we propose is same as the catalyst of hydrocracker, which is nickel molybdenum. So after this, it can see here that the product of hydrofinishing will go through high pressure separator, and high pressure separator will separate gas and also liquid. As it is obvious here that all the reactor names here are hydrocracker, hydro-dewaxing, and hydrofinishing, which they will use hydrogen. So hence, after all the reaction, will be use a high pressure separator to separate the hydrogen from the feed. So the gas will go up here, which is the gas will consist of hydrogen and also other contaminants. Then it will go through a scrubber. So the scrubber will be using lean amine as to absorb the contaminants inside the gas, so that only pure hydrogen will go up and will be recycled back as a will be recycled back to the reactor. And for the liquid, it will go through another separator, which is low pressure separator. From here, same process will occur for the gas, which it will go through a scrubber to separate the hydrogen and go back to and recycle back to the reactors. However, the liquid, it will go to a vacuum fraction distillation and produce base oil. So from here, so we can get our base oil, which is our group 3 or 3 plus product.
Next, I will explain the contribution, which can be divided into the completed part and ongoing part. For the completed part, first I conducted literature review on solvent extraction and hydrotreating. The findings that I got from this literature review is solvent extraction is not suitable for this project because solvent extraction cannot produce group 3 base oil. And for the hydrotreating, I can conclude that hydrotreating is not required for this project because the feed for this project has almost 0.1 ppb of sulfur. Secondly, I managed to sketch the first draft of PFD. The PFD gives the overview of the process involved for this project, so it can is our simulation process. My third completed contribution is developing the process through alternative, which I developed along with my group mates. For the ongoing contribution, first I do the report writing on chapter 4, conceptual design analysis. I screen the two alternatives that we have and justify why we choose the alternative 1 compared to alternative 2. Secondly, I conducted the HACCP simulation along with my group mates. So in this simulation, we follow the process flow diagram. And the last ongoing contribution that I did is mass balance. The mass balance must be performed in hand calculation and also from the simulation. That's all for my part. Thank you.
For the contributions from me that I have completed, the first one is a literature review on the catalytic dewaxing and solvent dewaxing. Next is to find the product demand. We already did that. And the last one is to tabulate the MSDS of the data that needed. And the ongoing things that I am doing right now is the report writing on chapter 1, which is the introductions, report writing on chapter 2, physical and chemical properties of base oil and side product, and the second draft of process flow diagram after heat integrations. And we are still working on that things.
Okay, next is what I have contributed for this group, where the first one is a literature review on clay treating, report writing on the previous accident related to loop base oil plant, and lastly is developing process route alternative, where for this one we have done it together as a group. Next, for the ongoing part, I am doing report on chapter 3, which is preliminary hazard analysis, where I have to identify the material and chemical hazard in the process, discussions on the possibility to reduce potential consequence of accidents, and also identify any requirement or compliance by local safety regulations and design guideline. Lastly, what we are doing right now is HACCP simulations for the whole process. So I think that's all from me.
For the contribution, I have completed the literature review on catalytic hydrofinishing and clay treating, as well as finding the demand and market price for Group 3 base oil. And the ongoing progress, there are two tasks, which are report writing on chapter 2, market analysis, and HACCP simulation.
Okay, as for the contribution, I already completed literature review on hydrotreating unit. However, since our feed from VDU contain less contentless sulfur. That's why we won't be using hydrotreating for our design. Next, I also completed the operating condition for hydrocracking, the catalyst, the temperature, the pressure, and the details explanation about hydrocracking. Next, we completed in a group of developing process routes alternative. However, the ongoing project of that I'm doing right now is high C simulation, mass balance, and also report writing on plant location as we propose for now is in between Kerteh, Melaka, and also Port Dickson.